Hello, everybody, and welcome to yet another edition of Scaleway Sessions. Today, we have a fantastic special edition for you today. We have another Ask Dr. Cube, Ask Dr. Cube, the Scaleway Sessions where we solve your Kubernetes pain. And with us today, we have an esteemed, welcomed, honored, fantastic guest with us today. Arthur, would you like to introduce yourself, please?
Thank you, Dan. So, my name is Arthur. I'm an SRE. I work at a French company called Pigment, and I've been working with Kubernetes for years now. Lost count. And yeah, I'm glad to be here and answer some questions for people.
Excellent. Thank you so much, Arthur. We're super, super glad to have you. For those of us who have joined us in the past, you'll note that Dr. Cube today looks slightly different from the Dr. Cube of last time. It's kind of like the doctor from Doctor Who. It's not always the same person, but of course, the doctor is here to help you. Also joining us on the broadcast today is Eli.
Hello. If you've seen the Scaleway session before, you know how I am. If you don't, I'm a dev role at Scaleway. I'm fortunate enough to work with Dan, and I am here to learn all things Kubernetes from our wonderful Dr. Q today.
And again, my name is Dan. I am the head of developer relations here at Scaleway. So, full disclosure, what you are watching right now was recorded before you're watching it. Collisions happen, there are conferences, things come up. So what we wanted to do is make sure to get that sweet, sweet Scaleway sessions, that sweet, sweet Kubernetes content out to you. And we're doing it, but we're not doing it live. So I'm gonna say right now, thank you to everybody that sent in some questions. Thank you to everybody that was collecting questions and then submitting them for us. We collected them all. We've got a list that we're gonna hopefully address today. If you are looking to get involved in the chat, if you're looking to get involved on the stream, like in previous sessions, we will be back next week. So don't worry about that. We'll be back live. Okay, so shall we dive right in? What do you figure, Arthur? Are you ready?
Yeah, let's do it.
All right, super. Now you mentioned you've been using Kubernetes for so many years that you've lost count.
Right.
Hopefully, in that time, you've accumulated some knowledge about kind of how Kubernetes works, ways of running it, and in that time, have kind of seen some problems and hopefully solved some problems. Would you say that that's correct?
Yeah, that is my main job.
Literally your job.
Yeah.
Fantastic. So we've got a list of questions here for you, and you know we've shared them with you ahead of time. Again, full disclosure, right? Are there any questions on here where you're like, yeah, that's the one. That's the one I want to start with, or should I just throw one right at you?
Um, I think I'd like to start with how to implement health checks properly in
How
Kubernetes.
to implement health checks properly. So the question specifically, I'm going to read it verbatim here to make sure we're all on the same page. It's quote, how do I implement proper health checks for my services?
So
End
it's
quote.
timely because we were just talking about telemetry a couple of weeks ago. So
That's true. And we'll be talking about telemetry again in a couple of weeks. So there we go. All right. So Arthur, where do you even, okay, first off, before we even get to answering the question, maybe just a quick overview. What are the words health checks in the context of services, in the context of Kubernetes? What is this question actually asking about?
Right. Well, in the context of Kubernetes, I don't think the word health check is actually used. I think we talk about probes, and we have three types of probes. We have startup probes that allow Kubernetes to know when your service is done starting up. We have readiness probes, which tell Kubernetes that your service is able to receive traffic. And then you have liveness probes, which allow Kubernetes to know that your service isn't stuck, basically. And so what happens with these three probes, how they interact, is that when your container starts up for the first time, Kubernetes is going to run the startup probe on a loop until that probe says your service is done running. And so that probe can be an HTTP request, or it can be a command you run, whatever you want. It's very flexible. Um, and when that command returns 0, or when that HTTP request returns 200, then Kubernetes is like, okay, so your service is started up. Now I'm moving on to the readiness and liveness probes, which are going to run forever, as long as your container is running. And once your readiness probes answer okay, then your service is going to start getting traffic. It's going to be added to the list of endpoints that make up your service. And so your pod is going to start receiving traffic and be able to process requests. If it fails that probe later on, Kubernetes will remove it from the pool, and so it will stop receiving requests, which can allow your service to catch up. Maybe if it accumulated like a lot of work and it's starting to be overwhelmed, failing your readiness probe is a good way to just calm things down. However, if all your pods do that, well, your service is going to be unavailable, right? That's something to take into account. And then the liveness probe, finally, and I think a lot of people misuse the liveness probe. The liveness probe, when your container fails it, Kubernetes will kill it, right? That's what it does. So that's really for situations where your service is stuck. Maybe it's deadlocked or something. Like it can't do anything anymore, so it can't respond to that liveness probe. And so your liveness probe should really just be, can I just process a request and answer to 200 without checking anything, without running any logic? Because then if you can't do that, it's probably a good idea to just kill your app and start it up again, right? And that's what Kubernetes will do. Most people use liveness probes, and they set them up the same way they set up readiness probes, and then they don't understand why their applications are getting randomly killed, especially usually when their applications are like have a lot of work to do, which is the worst time to kill your app, right? Because it's doing stuff. So yeah, that's what we mean by health checks in Kubernetes.
Right. So we're talking about that live check then.
Yeah.
Really, that is almost like the fail safe.
Yes.
Right. The check of last resort, the probe of last resort.
Yeah.
Right.
If you think about it, it means you use the liveness probe to signal to Kubernetes that your container should be killed, but that also means that your container can't kill itself, right? So it's really because your app can always just exit, right? If it wants to, right? You can always write that code. So if it can't do that, it must really be stuck. And that's when you signal to Kubernetes, that app is frozen, just kill it, get rid of it, and start another one.
Just we're going to try again, right? It's got some horrible zombie thing going on, and it's past all repair.
Yeah, whatever processes were happening on it are unrecoverable, so you might as well just nuke it.
What I mean, since we're on the topic, like kind of, does it make sense to sort of work backwards from the worst case scenario up, or does it make sense to sort of start with, some sort of application level check and then work your way to the worst case scenario?
I think the basic health check you can implement for like a web service, like let's say we're talking about a web API, which is like the common case. If you're talking about a web API, usually the startup probe is going to be a simple HTTP request. And if your service can answer that, you're good, right? I mean, your server has started, it's booted, right? It is running now. It can at least respond to HTTP requests. That doesn't mean
at a protocol level,
yeah,
the communication can occur.
Right. I mean, and the question is really, has it started, right? Does it make sense to start running the liveness probes now, basically, the readiness probes now, right? That's what the start probe means. It means it makes sense to start checking if I'm ready. This is really useful for applications that take a long time to start up. I'm thinking of, for instance, in Java, the Spring Boot framework is actually like very well known for taking a long time to start up because it's indexing a lot of stuff. And so that can take like a good 45 seconds. And you don't want to make it so that Kubernetes only only detects that your app is unhealthy after more than 45 seconds, right? You just want to tell it, I'm going to take a while to start. But once I've started, I want you to check my health every 5 seconds, right? That's what you want to be able to do. So you use that starter probe to buy yourself time when you're starting up. A lot of applications, they start up in a second, and so you don't really care about the start probe, and that's fine. And then you get to the readiness probe, which I think is where most people can get the most value the quickest, is by implementing a smart readiness probe. If you can do that, you're golden. Because that's how you can prevent a lot of services from actually receiving traffic when they shouldn't be. For instance, a lot of things for instance, let's say you have your web API is using a Postgres database, right? in the background, and it's accessing a bucket, for instance. It needs to use those, but it'll only use those when it's actually processing like actual API calls, right? It's not gonna. And so what you want to do is in your health check, connect to that database. Like run a simple query, make sure that that works. You want to connect to the bucket. You'll make sure that that works as well. And why? Well, because if you have a problem with, say, credentials, well, then your app is never going to get traffic, and you'd much rather that happen and your deployment to fail rather than giving a pod that can't connect to your bucket live traffic and suddenly giving your users 500 errors,
Mm.
right?
You
That's
don't want
what
to
you
drop
want.
legitimate requests.
Exactly.
So you send dummy requests first to test the waters. Yeah.
Yeah, exactly. And you want to send those pretty much all the time, right? Because the thing is, like most people think, well, if my credentials work once, they'll never fail, and that's probably true. But the whole point of the probe is you want to know about that edge case, right?
Mhm.
That weird situation where suddenly your credentials got revoked or something, or you have a network problem and you can't connect to your database anymore, right? And that doesn't mean you want to restart your app, right? If your database is going to reboot, maybe your readiness probe is going to fail, and your service is going to be taken out of the load balancing pool. And that's okay because your database is going to start back up eventually, right? And maybe it's not even going to be down long enough for your service to actually be taken out of the pool. Like this isn't instantaneous, right? Usually we configure these things for you get a probe every 5 seconds and you need to fail it like a certain number of times before we consider that your service is actually down. Um, and so when that happens, I mean, don't count on this mechanism to actually like quickly remove a pod, a non-working pod from your service, but you can use this to instead of responding poorly to users, start considering that your service is unreachable, and so the caller can actually adapt, right, to that. Like most callers can really adapt to 503 errors, which means service temporarily unavailable. That's what it means, like in the
What do you
HTTP
mean by
script.
caller in this context?
It can be another one of your services.
Mhm.
It can be your front end. It can be your mobile app. It can be anything really.
Okay. Anything making those requests.
Right, exactly. But I mean, from my point of, like for instance, if I'm the consumer of an API, right, and I start getting 500 something errors, right? Like server side errors. Um, if I get 503 errors, what I figure is, oh, there's downtime. Okay, I'll just retry, right? But if I start getting, I don't know, like say 502 errors, right? That's bad gateway. That what that means is, okay, so that's not like they're restarting a database. That's a load balancing problem, right? This could last longer. So
Mhm.
maybe retrying isn't the good thing to do. If I get just a naked 500, I get no info. I don't know what
Yep.
to do, right? Is this error temporary or not? Is my input making the server crash? What's happening?
So it's
Right?
about sort of gracefully handling different failure states.
Exactly. Well, it allows the caller to do that, right? Because I can decide, like my front end can decide what to do with this error, like and be like, oh, the backend is temporarily unavailable. Maybe I don't know, just put a spinner up and retry and see if that fixes it. And if the issue lasts, I don't know, like 10 seconds, maybe I'll put up a message to the user, be like, okay, there's a problem. Here's the link to contact support, right? Or a nice message like, our team is on it, whatever. And
Or if
usually
it's
you
like a
are on
piece
it.
of middleware, you just continue to fill up the queue with these requests and kind of just keep
Right.
going.
Yeah, exactly. Like you're
Yeah.
saying this service is unavailable, right? That's important. And that's what happens if your pods disappear from the endpoint list, right? Anyway, so health checks. To go back to the question, how do you implement proper health checks? If you're implementing a web API, have an endpoint like /health, for instance, that checks basically the if the structure of your app is okay. So if you're an HTTP server, that you can respond to HTTP requests, right? Um, and check that you can access your dependencies. You don't need to actually like perform actual health checks of your dependencies, but just at least check that you can use them, right? You can connect to your bucket, you can connect to your database. Um, and if you do that, that brings a lot of value. And if you have more dependents, like multiple dependencies, you'll be really happy to do that sort of check, right? You check your database, you check your bucket, you check your, I don't know, your Redis cache, you check your RabbitMQ messaging queue, whatever. Um, you can have a lot of dependencies, but you want to do that. And if you have a lot of services, you want to put this in a shared library that everybody can use quite easily. That way, all your services do it out of the box. That's where the real value is.
Right, now that makes sense. So this, we're going to draw some parallels here. If it's the first time maybe that you're encountering this, you're watching this, and you're thinking, "Oh, this sounds kind of interesting. How does this work?" There's a good chance you've seen patterns like this in the past, right? So if coming from the Linux world, thinking about systemd, there's ways that you can say, no, like wait for this to happen, and then do this. Wait for that to happen, and then do this. And it's okay if this takes a while. Like, don't just fail and bail out, right?
Right.
So these sort of like logic paths, and I think the important thing here that we keep kind of coming back to, however, is handling these conditions. So on the one hand, you need to intelligently set up these types of probes, which we've now discussed, and kind of which order they go in, and a little bit how to use them. And the other side of that is it's nice to have the probes and it's reporting this information, but then you need to be able to deal with that information, right? And that's where you're going to have some application logic to deal with: graceful retries, back off rates, send something to a queue, make it eventually consistent, et cetera, et cetera, et cetera. So if I'm understanding the answer to the question correctly, which again is, how do I implement proper health checks for my services? It's on the one hand, utilizing the probes in the way that they're meant to be configured,
Right.
and two, making sure that whatever's consuming these resources can deal with the results of the behavior of these probes. Is that correct?
Right. I think the key thing, if you're starting up, like if you don't have health checks today, or you only have like a basic health check that just checks if your server is responding, the best thing you can do is start pinging your dependencies. Like that's the thing people should do, is ping your dependencies. Make sure that they're just there, right? That's all you need for starters.
And
Do
I
you
mean,
find
go ahead.
do you find that that's the source of a lot of issues? Is that it's actually sort of dependencies being flaky or hard to reach? Do you sort of is that where you see a source of a lot of these errors coming from in real life, as it were?
I wouldn't say it's the source of a lot of errors, but okay. So I'm an SRE, right? So site reliability engineer. I want things to be reliable, and the core lesson for all new SREs is that they need to learn that nothing is ever truly 100% reliable, and so you need to think about your application's reliability, um, acknowledging that your infrastructure is going to fail at some point, right? So I gave the example of the bucket. Where I work, there's this one service that uses a bucket, and it uses OIDC to authenticate to that bucket, right? And so the infrastructure is responsible for setting up that OIDC. So the container just doesn't do anything. It just uses the SDK and connects to the bucket. And that works fine. And then suddenly, we're getting a ton of 500 errors on a single pod in a service with 10 replicas, and it's logging this cryptic error saying it's not finding an environment variable related to that SDK's authentication. And what we had to figure out was, well, we eventually figured out that OIDC setup had failed for just that pod, right?
Huh.
And so we figured out why. Like, we were able to fix it. Just delete the pod, and you're fine, right? But we would have much rather have a situation where that pod just never received any traffic to begin with, right? I mean, so it doesn't solve the issue, but it stops the issue where it is, right? It makes sure that an issue with a dependency doesn't make your service less reliable.
Mm. Even if the fix is just nuke it for an orbit and restart, and you never understand, what exactly went wrong, which I'd hate that, because I always want to know, like, how did it fail? Why did it, what was the edge case? But you don't have to know that in order to contribute to reliability of your app.
Right. I mean, yeah, I mean, thing is, like, it's important to understand, like, we did dig into it and we didn't find the root cause, because at one point we reached the barrier of the managed services we were using, right?
Sure.
And we're like, okay, so this bug isn't on our side. But the thing is, if you count the number of pods we start that have this OIDC setup, we've run thousands, maybe tens of thousands of pods in production.
And this has happened once.
And twice. Yeah, it's happened
Oh,
twice.
yeah. But it's not actually worth your time trying to debug too much.
I mean, it's not just that. It's that it's completely. It falls into this reasonable unreliability of a service, right? It's not reasonable to expect a service to be 100% bug free. It's
Yep.
not going to happen, right? If you expect that, you're going to be disappointed. So just if we have a service that fails 0.1% of the time, we're going to be like, okay, well, we're going to do our best to make sure that that doesn't add 0.1% to our downtime, right?
Yep.
That's the best you can do.
It's a bit like having a workforce and expecting them to never be off sick or something. That's not actually reasonable. You just got to make sure that you've got kind of redundancy or ways of handling that properly, which,
Yeah, exactly.
Speaking of reliability, you mentioned, Arthur, that you are literally an SRE, a site reliability engineer. And as I understand it, you are going to be speaking at an upcoming SRE conference. Is that correct?
Yeah, in London next week.
Excellent. So that's at WTF is SRE, if I recall correctly, right?
Yes, exactly. The 2023 edition.
Excellent. Right. And what are you going to be speaking about at this conference?
I am going to be giving a talk called Secrets, Race Conditions, and Statelessness. It's basically a talk about managing secrets in Kubernetes. And well, I mean, how I started with a simple solution that most of the community does because it's the easiest, and how that bit me at some point. And so how I tried to make things, to keep things simple, but with a different approach that could not bite me in the same way. And then how I joined my current company, where neither of those approaches were sufficient for our needs. And so we had to come up with a third one. And so this talk is about those three methods, basically. It's quite an advanced talk, but for people who use Kubernetes and for whom security is important, and so managing your secrets is important, I think it'll be interesting.
Excellent.
Yes.
Well, if you happen to be in London, 4 or 5 May, Arthur's going to be speaking there. If there are still tickets, you should grab some. If there aren't tickets, hopefully the recordings will be made available later. Arthur, is this maybe a talk you're going to be doing in the future somewhere else for people who can't make this one?
I'll be doing it again. That same talk, improved based on what I learned in London, at the end of May at Scaleway's Kube Talks.
At Kube Talks, excellent, which is, of course, a great way to transition to Kube Talks number 3. So Kube Talks, if it's the first time you have seen our broadcast, Kube Talks is our Kubernetes monthly get-together. We get together, we talk about Kubernetes, hence the name. I say Kube Talks, other people say Kube Talks, so we can argue about how this is pronounced, and that's all well and true. We had to have 2 guests come on, and this is live. This meetup happens in Paris at the Scaleway offices, and Kube Talks number 3 will be featuring Arthur on the 30th of May. And as you mentioned, it's going to be about everything that he learned, with that adventure. So if you're going to be in Paris, you can't make the one in London, but you're going to be in Paris towards the end of the month, please come out for that. And as always, keep it locked on our socials and whatnot, of course, to get more information about that going forward. All right, enough about the plugs. Yeah, we've got more, don't worry. So, don't worry about it. We've got a few more to go. Would we like to tackle another question? Have we talked about the probes enough, you figure?
Yeah, I think we've covered it.
Excellent, excellent. So we talked about the health checks. probes and so on and so forth. I have a question here that's on here that I get asked this question a lot, and I would be really interested to know to see how you respond to it, Arthur. Is the big one, which is, and this is the question. I'm going to read it verbatim. I've heard of service mesh. What is that, and why would I need one? What do you figure, Arthur?
This actually relates to the health checks, but I'll get back to that. Okay, so a service mesh is basically your infrastructure helping you manage a lot of services in a standard way. And what I mean by services is, for instance, if your app is divided into many services, or maybe you run a lot of different apps, right? Basically, you're running a lot of stuff in your cluster, and a lot of these things are communicating with each other. And for each of these services, you have a lot of shared concerns. You need health checks, you need observability, right? You need logs, tracing, whatever. You need retries. We talked about retries, right? If your system failed temporarily, maybe just sleep a second, try again, or maybe don't sleep, just try again instantly. Sometimes that solves a lot of problems. And a service mesh is a part of the infrastructure that does that for you, so your applications don't really need to think about it too much. And so I think the most famous service mesh today would be Istio or Istio,
Istio?
Istio. Pronounce it how you want. I've heard both. And the way Istio works basically is that every pod in your cluster is going to get a tiny little HTTP proxy that's going to latch to it, and incoming requests will go through that proxy and then to your application, and outgoing requests will go through that proxy and then to their destination. And so what that allows is for the proxy to do stuff with those requests. So it can log them. It can collect some tracing metadata if you want to know, okay, so this request went to this service, then this one, then this one, then this one. And in those logs, you can log a lot of stuff like HTTP response codes, or if the request failed, maybe it was a connection refused because your application crashed for some reason. And so the proxy itself didn't crash, so it can actually respond like invalid HTTP, or it can even retry itself before responding. Like your application didn't failed, maybe, I don't know, something happened. You try again, and the proxy can try again for you, right? And do all this stuff. And the idea is that application developers, when they deploy their app to your cluster, they don't actually say, okay, I'm manually adding this proxy into all of my pods, etc. They don't do that. The infrastructure does it. The cluster does it. Like for any new pod, it's going to edit the pod and add that proxy in, right? And it doesn't have to be a proxy, but the important bit is that you've got this piece of software that is capturing and managing and observing all traffic and all communications between your services, right? That's the important part. And Istio does that, but others do that. Cilium is working towards that, it looks like, with a different implementation. We'll see if it gets there. Anyway, so that's a service mesh. To answer the question, do you need one? I'd say nobody needs one.
It's a very senior developer answer. It depends.
Right. Yeah, that's the thing. It depends, but I know that, I mean, deploying a service mesh or Istio and configuring it properly, etc. There's work, there's stuff to learn and understand. There's complexity there. Lots of foot guns. Yeah.
Well, I can imagine if you've misconfigured, if it is a proxy and you've misconfigured it, you could get into a state where just traffic isn't getting sent at all to something, right. Or
Yeah, that can happen. Especially like the first times when you start getting used to it. But once it's set up, the observability gains and the reliability gains are huge.
So in this situation where, because this is the one that I grok the easiest, where it is like a little HTTP proxy, does that have insight into sort of metrics and the workings of the app within the pod that would be hard to get at otherwise? So, for tracing purposes, you've got your request has come in and the proxy's sort of tagged it with stuff. Could there be extra context that you get for your tracing that comes out of having this sort of, is it a sidecar? Would you call it a sidecar?
It
That's
is a
sitting.
sidecar.
Yeah. So, for example, like it so happens that this request took this long and it used this much memory or something.
Okay, so there's two parts to that. The proxy, like you're talking about observability, and the proxy can measure some stuff, but kind of in a black box way. It doesn't really know what's
Okay.
happening.
Yeah, that's a very succinct way of, like, I was asking, is it a black box or can you
Yeah, it's
see it? Yeah.
it's kind of a black box because the proxy knows that, okay, so a request came in to this endpoint, it took this long to respond, and it answered with this, right?
Okay, so you wouldn't necessarily have metrics about, oh, this is taking, like, the IOPS here is really slow or something.
Right, exactly.
Gotcha.
If you want that, you're going to need to add observability elsewhere, and this is where tracing is really useful, because the idea is that when your request comes in, usually the first entry point into your cluster is part of your service mesh, right? It's a proxy in front of your ingress controller or something, right? There's something there.
Yep.
And the first thing it does is it generates a request ID and just adds that
Okay.
in. And when it passes the request to your application, there is that request ID in the headers. of
And
the
if
request.
you've got, open telemetry going on inside
Right.
actually your application logic, it has that, you can piece that all together.
Exactly. Yeah, you can add that in. And so the way we use that is that, for instance, a request comes in, reaches our gateway, which is part of the service mesh. And the first thing it's going to do is going to ping this service to know which data center the request should be routed to, because Pigment is a global application. And so it pings that service, gets a response, then routes that request, the original request, to the corresponding data center and then therefore the corresponding pod. And that reaches that pod sidecar, which logs something, then forwards it to that pod. Maybe that pod sends an outbound request to something else. And the idea is that with these, we have that trace, like we know.
Yeah, we can build that complete picture.
Exactly, and that's very, very useful. We don't necessarily like know, okay, so this request took this much memory, but you can find out, usually you can find out like because of symptoms, like your application crashed in middle of this request, or this request timed out, right? And where did it time out? Well, it timed out connecting to the database. Oh, you're like, oh, okay, so I know I need to look at the database. And it's things like that. And your application can add whatever information it wants to those traces, which is very useful because you can actually add a lot of context. And in fact, our gateway adds in context about the data center it's sending it to. Right?
That's very cool.
Yeah.
Yeah.
I mean, and so it's a big setup, and observability is always a lot of work. It's less work if you pay for a managed service, but that can be expensive. But in the end, it can be a huge boon in helping you understand what's going on, or more importantly, what went on in the past, because that's usually what you're investigating.
Yes. I mean, as your systems become sort of more complex and you end up dealing with sort of, situations where, 2 out of these tens of thousands of pods went down in this way. If that turns out to be something that you really do have to debug, I imagine that kind of data and the tracing being really invaluable in actually digging down into a specific scenario.
It
I
is.
mean, we had a couple of weeks ago on Scaleway sessions, a friend of mine, Martin Thwaites, who is a Honeycomb dev advocate and also works a lot on open telemetry. So we've had, like, it's something that I really want to get into, is learning all of this stuff. And Kubernetes seems to be something where there's a lot of work going on with that. I mean, you mentioned 3 services just now, like Istio, there was somewhere else, and Cilium.
There are others that I don't know. Like, I don't know the entire list.
Mm-hmm.
We use Istio at Pigment. We also use Cilium, but only as on the actual networking layer.
Mm-hmm.
And I know that Istio, for instance, is working on a different implementation that doesn't use sidecars. which
Interesting.
I'm very much interested in, because that could have a lighter footprint, and most importantly, wouldn't require restarting applications to add a style in.
Yes.
That's the thing, right? I mean, if your application is deployed and you don't have a style in there, adding it in requires shutting your application down, and then restarting it, which is fine if it's like a stateless service, but if it's a database, that can be not ideal. Um, Especially if it's just to experiment and stuff like that. Maybe you want to go back and then you need to shut it down again. And so they're working on something called ambient mesh, where
That's a
you
great
deploy.
band name also.
Yeah, where the idea is that the service mesh is deployed not in each pod, but on each node, and then just
Oh.
grabs the traffic of everything happening on that node. It's a smart approach. I'm looking forward to testing it. It's not, I wouldn't say, I don't know. The
Is
people
it
I've
still in
talked to,
development? Sort of.
yeah,
Yeah.
I mean, it's been released, but they've been saying maybe not 100% production ready yet.
I do like that. That's a thing that we can do now as developers. Is I have a talk that I'm doing soon about running public betas, and that you can say, okay, this thing exists, and we can try it out, but here are the drawbacks. And especially with open source, if you're not trying to sell something, it's okay to do that. You don't have an incentive to pretend that your thing is already
Right.
perfect and has all the bells and whistles, which I really like. It always just makes me happy to see, because love that good communication with your developers. Thinking about restarting services, there is actually a question on here that I was really hoping we would get to, which is, I'm just going to read it out again verbatim. I have databases deployed within my cluster. If I change a field in their custom resources, will that restart those databases? Do I need to wait for a scheduled maintenance window in order to update these resources?
Right. So that question is basically, it's a question about operators, basically. When we're talking about custom resources in Kubernetes, we're talking about resources that are not built into Kubernetes, but were added into an existing Kubernetes cluster, right? The Kubernetes API is very flexible. You can define custom resources, and we call these custom resource definitions, or CRDs for short. And usually when you add CRDs, you also add an operator, which is just a piece of software that reads those custom objects, custom resources, and does stuff in response. And so this is a common way of actually deploying databases. You can deploy a database as a simple pod or stateful set or whatever. But we've built higher level abstractions where you have a custom Postgres resource in the Kubernetes API that you actually can create and edit and things like that. And the operator is responsible for seeing that resource and then doing what needs to be done. So deploying the actual Postgres pod, but maybe setting up a cron job that does backups, whatever.
And so you can contain all that logic within one sort of unit.
Yeah, exactly. And most importantly, basically what an operator is, like the term operator like predates Kubernetes, but we were talking about people. The whole dev and ops thing. Well, the ops were the operators. Basically, what we've taken is the expertise of running a specific piece of software, and we've coded it. And this is the operator we're talking about, the Kubernetes operator. And so we can operate that piece of software for you. And the custom resource is how you tell it what you want. Thing is, let's take the example of Postgres. There are lots of operators, so I'm going to try and be a bit vague, but that's not the point. If you have this custom resource that's saying, so I want a Postgres instance. It's got this much CPU, this much RAM, this much disk size, this content in this configuration file, maybe, or these settings, etc., etc. Part of these things, like some of these settings, like for instance, the amount of CPU, they may require restarting, like recreating the pod, right? But increasing disk size, not necessarily. Like some volumes in Kubernetes can grow without needing to be unmounted, right? Depends on the implementation, but that's doable. Or the contents of a configuration file, well, that depends. If that configuration is passed as environment variables, then you need to restart the pod. But if the operator is capable of actually going into the running pod and editing the file himself, then you don't need to restart the pod, right? And then it can signal to Postgres, hey, by the way, I updated your configuration, just reread it, right?
Yeah.
And so the operator knows how to manage Postgres specifically, and so it knows how to do that.
Okay.
So the real question is, when you're editing this custom resource, is if
How
I
do you
change
know?
this field,
Yeah.
what's going to happen?
How do you know which is which?
Right, exactly. Yeah. How do you
Without
know?
having to have all of that knowledge of the operator in your head.
Exactly. So in an ideal world, you Google your question and there's documentation that answers very explicitly. That doesn't happen very often. So you usually end up testing it in a staging environment, for instance. That's a good idea if your staging environment is very similar to your production environment. So, for instance, in production, you have maybe 20 Postgres databases managed by your operator. In staging, you only have 3. Well, that's fine, because in staging, you can break it. You don't care, right?
Yep.
So in staging, what you can do is just make the change you want to make in production and just see what happens. That's a good way of knowing what happens. But that's assuming your staging environment and production environment are very similar.
Yeah, maybe I'm using my SQL.
That's a big
in
if.
Staging.
Yeah.
Maybe it's a really tiny thing and I'm using SQLite. A completely different world.
Yeah, exactly. So that's why it's important to have like a sort of non-production environment where you can try stuff. Or even if you're using your production environment, maybe you can deploy another Postgres database with by creating a new resource that looks like the one you want to change, right? And so
Version
you
2
use that,
final.
and then you change that one
Yeah.
and see what happens. You can do that in production if you want, right? I prefer to do it in staging, but to each their own.
Yeah, and it depends what constraints you're working with. Again, if
Exactly.
it would be spinning up an entire new staging environment, well, you already have an environment that's that, and it is production. So
Right. Exactly.
Yeah.
So you can do that. And so you kind of end up testing it. And then the next step, if testing it is not an option, which happens usually because you're doing a change that is very specific or something like that, you may want to look at the operator's code, right? But Kubernetes operators, they're not necessarily simple to understand. Like if you're not used to how Kubernetes works and how operators and controllers work, if you don't know how to read Go, that can be tricky, very tricky. Or sometimes maybe you're using an operator that's not even open source. I've been in that situation. It's very annoying to try to reverse engineer something when you don't have access to the code. But sometimes that's what you need to do. Or usually, if you're using something closed source, you can call support and ask them. But you're not going to necessarily going to get a very quick answer depending on how good their support is. I'd say the best way, the most reliable way, is test it. But to be able to test it, you need some place where you can do those kind of tests, and so where you can recreate production-like setups, basically. That'd be my recommendation if you need to do that.
Cool.
So in the case of this question, then it is the classic case of it depends.
Yeah,
Right.
we had that answer earlier as well.
Yeah.
Right.
Yep.
Yeah. I mean, that's just how it goes. Unfortunately, in the world of software, in the world, especially of distributed systems, large-scale systems, and Kubernetes, if at any point in time you're putting Kubernetes into production, you've already got a big thing happening, right? There's
Right.
no such thing as a little bit of Kubernetes in production, right? It's
Right.
already a whole deal. So really the answer to this question then is, if I change a field in the custom resources, will that restart the databases? Maybe.
Yeah.
A good way to find out is to try it outside of production first, and then deal with that. In the case that it does not restart the databases, in the case where you change the field and everything just kind of keeps going, that's a pretty straightforward scenario. We really don't need to wait for a scheduled maintenance window. If you change the resource and something breaks, some sort of failure mode is engaged, some sort of back off mode is engaged, right? Waiting for the scheduled maintenance window in that case makes more sense.
Exactly. Yeah. I mean, where I work, there are lots of changes we sometimes do on databases, and some of them we know they don't require the database to reboot or anything. And so we do them when we need them. But we have a backlog of changes that are planned for 3 weeks from now, which is the next maintenance window. And so at that point, we're actually going to put the website under maintenance. Like literally, the website is not going to work for a little while, and then that's when we're going to do these database restarts, etc. But we need to be, for that to be quick, because we want it to be quick, we need to be prepared. And getting prepared means practicing in a production-like setup, right? Again, right? You don't want to, like, doing a database operation on a production Kubernetes cluster and doing it locally on your laptop with Docker is not the same thing.
No. And I mean,
Um,
even with all the testing in the world, it's not always sufficient, right? I mean,
Yeah.
I know of a company that recently had a maintenance window that went for several hours despite their dry runs all being totally fine. I mean, this is not necessarily a Kubernetes specific question, but what do you do in that scenario? Would you just roll it all back? You know, are there certain changes that you would be doing in those maintenance windows that you are more certain of than others?
Okay. Well, first
Rolling
thing,
back is sometimes a dicey proposition, right? We all want to
yeah,
think, oh well, we'll just revert to a
I can
previous git
just
commit,
Control Z,
but
right? But
right.
not always.
I think the first thing to do is don't panic. Um, right. Yeah. I mean, it's the same way when you see firefighters entering a burning building and they're calm and they're not running, right? That's for a reason, because if you run into a fire, things, bad things could happen. But if you walk into a fire and you have a cool head, you can be professional about it and actually manage a complicated situation, right? Yes, a cool head. Yes. But when you have, like, you've basically broken production,
Mhm.
right? That's what we're talking about.
and who hasn't?
I
Yeah,
once,
exactly.
yeah,
Right.
I once
Um,
was sit down prod.
my job is to break production often, but very little. Right. So if you do that, if you've broken production, stay calm, and then try to get production back up and running as fast as possible. So you're not trying to understand what happened. You're not, etc. But you're trying to get production back up, right? And to do that, sometimes rolling back is the correct idea. Sometimes it's not. For instance, rolling back is basically doing another upgrade. If you haven't tried that out beforehand, that may make things worse.
Yeah, depending on how specifically it's broken currently.
Right, exactly. For instance, I know that, like, this is a tangent on deployment pipelines, right? But where I work, when we deploy to production, right, we deploy to this sort of pre-production environment, what we want to deploy, and then we deploy to production. And then once that's done, we go back to the pre-production environment and we roll it back to see what happens. And we call this a rollback test. Like, could we roll back production right now? Basically,
Yeah.
considering like all the changes we made to our database, et cetera, could we roll back production? And the answer is most of the time these tests fail, right? And they're like ordinary software tests. They fail because they detected issues, like real problems. And thing is, when we have a production incident, we do not roll back if those tests fail, because we know if we roll back this version to the previous version, something is going to break. So we need to fix forward. We need to hotfix, right? We need to patch this.
Right.
We can't go back, right? And it's important to, if you want to take a step back, to be sure that it's something you can actually safely do.
And I imagine the more, say you've got like a whole set of changes that you did during that maintenance window,
Right.
sort of unpicking which ones need hot fixing and which ones went through and which ones were complicated by an earlier breakage would become really complicated. I guess it's an argument in favor of more regular maintenance windows, but that might not
Yeah,
make
it
sense
is.
from a business perspective. So
It is. It's way better to make a million tiny changes than one big one. It's
Well,
way
this is
better.
one of the things that gets mentioned in the state of DevOps reports that have been put out for years at this point, right? That organizations which are deploying more regularly, and by more regularly, we're talking multiple times per day,
Right.
in some cases multiple tens of times per day. These are the organizations that are actually reporting better reliability metrics, are reporting less downtime, right? Even as they are reporting more individual incidents, right? Because mechanically, if you deploy 100 times, a certain percentage of them are going to have incidents, right? But if over the course of the lifespan of your company, you deploy 100 times and 5% of them are incidents, that's really, really bad, right? But if you deploy 100 times over the course of a day and 5% of them are incidents, well, you're solving them right away.
Exactly. Yeah. I saw this on Twitter the other, I think it was this morning, a graph, this platform as a service type thing. The CEO tweeted a graph of a single client, so a single company that deployed, I think it was 4,500 times over the past 30 days. And so if you think about it,
It's
so you can see the
150 deploys
graph,
a
right? So
day.
they don't deploy on weekends, right? I thought at first, like he said that's like 150 times a day on average. I'm like, well, no, because there's not weekends, so it's even more. It's more like 220 times a day.
250. Yeah.
It's more, yeah, so it's 200 times a day. And if you think about it, okay, so they're working maybe what, 10 hours a day, maybe. That's the time window during which they're deploying.
Yeah.
Right? They're
Depends, I
hard
guess, if you
workers.
have globally distributed teams or not.
Right,
But still, yeah.
Yeah. But assuming like every engineer is deploying like 20, like over 10 hours, over 10 hours, or span of 10 hours, like you get in the morning, you merge your PR, deploys.
That's every 3 minutes.
Pretty much. Yeah, exactly.
Whew.
That's a lot.
That's a fast CI pipeline. My
Right,
goodness.
exactly.
That's the thing that's the most impressive.
Yeah.
Right, exactly.
One CI pipeline only takes 3 minutes.
Right. And I've seen people do this. There's different approaches, right? For instance, where I work, we deploy once a day, right? And we know that's not a lot. But what we do, however, is put a huge emphasis on pre-deployment testing. We have a huge, like the biggest part of our deployment pipeline is actually testing to make sure that everything is okay. We actually run our end-to-end tests twice. We deploy the version that's currently in production. We run our end-to-end test suite. So that populates the databases, right? Gives us like production-like data. Then we upgrade to the version we want to release, and then we run those tests again.
Yeah.
Right? We want to make sure, because when you run tests on your PR and stuff like that, you're always running them from scratch. And we want to make sure, do our new features actually work on production data, right? And we've caught issues more than once this way. And so we end up deploying once a day.
When in the day do you do that?
Pardon?
When in the day do you do that? Is it like 3 p.m.?
So the pipeline triggers early in the morning. I think it's something like 6 a.m. The idea is that when you get there in the morning, either a test failed and you can start investigating why. We have a person who's dedicated to that role every week. Or it went well and you can just click on deploy and you're done. Right?
Nice.
The idea is, but I've seen companies do the exact opposite, where they have virtually no testing at all, like no end-to-end testing. They have unit tests that run very quickly, so that's how you deploy in like 3 minutes, because you need to build and test and deploy in less than 3 minutes. Usually you are building very lightweight services, when you basically what you deploy is always a 5, 10, 15 line change, right? And you have good observability, like good dashboards, where you deploy, you look at your dashboard. If your graph takes a wrong turn, just you just revert that commit.
Git revert. Yeah, exactly.
You're done, right? I mean, or
and that's another deploy as well. So
right, exactly. It's another deploy. It's gonna go quickly. Like you don't care, right? And the thing is, since you're not making any huge changes, you're basically always testing in production. And for a lot of applications, that setup actually works really well. Like for non-critical applications, that works really well and makes teams extremely productive.
It makes teams willing to take risks as well.
Yes.
Right? Because any one risk is so minor that like whatever, we can just fix it a couple minutes later.
Right. Exactly.
Right?
I imagine it makes you much less afraid of breaking production as well.
It does. And also it accelerates multi-step maneuvers, right? People don't talk about that much, but for instance, let's say you want to add a column in a database, right? In your services database, when you deploy, you're basically going to run that SQL query that's going to add that column. But at that point, right, you have the old version of your service that's still using the database.
Mm-hmm.
And so you need that column to be optional in a way,
Yep.
right? And that needs to work. And then once you've upgraded to the version of the service that can actually use that column, you can upgrade that next to a version that actually fills in that column, actually puts data in there, and then uses that data, and then eventually you stop making that column optional, right?
Yep.
But there's multiple steps there. If you deploy once a day, that can take a week.
Yep.
But if you deploy every 3 minutes, that's going to take half an hour.
Yeah.
Right? That's a very big difference in productivity. And that's something you win if you're willing to sacrifice testing.
Yeah, the time it takes to run that pipeline, regardless what steps of it are manual or
If you're willing to test in production, you can save a lot of time. But to do that reliably, you need good observability.
Mm-hmm.
And we actually just recently
had
a gentleman on from Honeycomb.
I was picking him up earlier as well.
Right, if you've ever encountered Charity online or in real life, or if you've even ever heard of Charity, you know, testing in production is her jam, and Honeycomb is all about that, and having that observability tooling, especially if you talk about distributed systems and whatnot. Having good observability tooling is pretty much primordial. Right.
Yeah, that was how I met Martin, actually, as I ran into him at NDC, and he had the I Test in Prod shirt from Honeycomb, and I was like, man, I got to get a photo of this for the people I worked with at the time who tested in production, but without perhaps some of the intentionality that we've been discussing.
Right.
Excellent. So we are bumping up on time here, but if you're okay, Arthur, to get in another question, if you have the time, I'd sure like to get another one in here, if that's okay with you. Is that all right?
Yeah, my pleasure.
Excellent. Now, is there anything on the list here that looks appealing to you that you want to tackle, or should I just throw another one at you?
I think depends.
It depends.
There's two questions that I like. I'll just go with the first one. The Helm or customized one. It's the eternal question.
Okay, sure. So the one about Helm or customized. So the question is, and I'll read it again verbatim. Should I use Helm or customize with a K to deploy my application? Question mark. Or something else? Question mark. So again, let's start at the beginning with this question. First off, we talk about deploying applications. We've talked about deploy pipelines already at length, so this is a good transition. What is Helm? What is customized? What family of software, of solution are we talking about here?
Right. Okay. So when we deploy software to Kubernetes, we're basically creating objects in the Kubernetes API, where we're declaring deployments and config maps and services and ingress and things like that, right? Tons of objects, which is in basically a simple CRUD API. To manage these objects, the community really likes to serialize them and write them as text. That makes them easy to read as humans. And so the format that we've chosen is most often YAML. But you could also write it in JSON if you want. But YAML is easier to read for a human. There's less boilerplate. Or actually, there is more boilerplate, but it's invisible, so it's fine.
So white space.
Yeah, exactly. And so what Helm does is allows you to write templates to generate that YAML. And then when you deploy your application with Helm, right? Because Helm has two core features. There's one that's templating, right, to avoid duplication or maybe simplify things, right? If you want to implement some sort of logic or a loop in your YAML, you can do that with templates. And then the second thing is Helm remembers what you deployed previously. And so when you upgrade your service, it knows what to add, what to edit, and what to delete. And that's very important. What to delete is actually very important. A lot of people forget about that, right? If you use kubectl apply, it's not going to delete stuff, right? Yeah, if something isn't in your YAML anymore, but it was last week, well, then it's still going to be there.
Is there some sort of garbage collection thing that you should do after that? In the
Honestly,
kubectl world?
I mean, I don't know, but you need to keep track of what you're doing, right? It's the same
Mm.
thing of what you've done in the past, right? You need to keep track of the resources you own. Um, and so when Helm does that, it stores that in the Kubernetes API itself, right? In like secrets. It just stores that metadata. And so Helm does that really well. Customize is different. Customize is not templating, it's more patching, basically. So you start with a working resource and then you're going to patch it, right? You're going to add stuff on top of it. And you can add like a lot of patches, right? But you can't do things like loops or if statements or things like that. And that's all Customize does. Customize then generates YAML. But it doesn't do any state management, right? So if you use Customize instead of Helm, you need something else to do that state management. Today, we use tools like Argo CD or Flux to do that for us. And they basically all they do is state management. And that's so at that point, you don't need Helm's state management anymore. You're only
Mm.
using Helm's templating, and then or you're using customized patching system uh, to manage all that. Um, in my experience, like the modern practice of using Argo or Flux, which we call GitOps, which is basically everything is your templates, your customized config is in your repo, and to deploy, you push to that repo,
Mhm.
and Argo just watches that repo and applies basically.
Mhm.
Um, that practice is great, but you don't need state management anymore. So you don't need Helm's state management, and so you're basically the debate is between templating and patching, right?
Mhm.
If you're just starting off, Helm is simple enough to grasp, right? I think. Plus, if you're deploying third-party software like an operator, it
Mhm.
usually comes with a Helm chart that you can just use out of the box. And Helm charts are great abstractions, and that's great. However, if you're deploying your own service, you don't want it to be like a black box complicated template, right? You want everybody in your organization to be able to understand and read it, especially people who don't use Kubernetes professionally and who don't know Helm's templating syntax. And I mean, you're
Yep.
making things very complicated for other people
Right.
if you use Helm templates. Customize is easier to grasp at that level. That being said, having used Customize a lot and Helm a lot, Customize is I prefer Customize's patching model, but the implementation is imperfect, and so there's some
Right.
things that you feel should be simple, but are very complicated to do. Basically, because you can't do any templating of any kind. Like at some point, you just want to inject a variable somewhere, and
Uh-huh.
you just can't, right? Whereas with Helm, it's the opposite. Like everything is a template. There's more template than YAML because everything needs to be customizable, and that's it's Helm. Um, and I think the best answer is I've heard people say Helm first and then customize later. I've heard that. You can technically do that. Like run Helm template. It just
Mhm.
renders the templates, and then you run customize on top of that. Right? You patch that output. In theory, that works. In practice, it doesn't bring much.
Mhm.
Um, and so I think like the every single company I've seen that uses Kubernetes at an advanced level and deploys lots of services that have some configuration in common, but a lot of variation as well. They used custom tooling, right?
Right.
We're talking about code generation, and this is not complicated to actually write. What we do at Pigment, for instance, is we generate customized configuration, right?
Mhm.
Because customize on its own is not enough, is not a good enough abstraction.
Right.
And so we wrote a custom one where we have a specific YAML file that only contains the information we actually need to change
Yep.
and has escape hatches where you can write raw customized configuration. And if you use that, it turns out and then you run our tool and it just generates a ton of
Exactly
customized code
what
that you
you
don't need
want.
to manage anymore, right? You
Yeah.
don't need to write it. You don't even need to read it. Because your state management tool like Argo is just going to tell you the final diff, right? So you don't care how much YAML it actually generates.
Mhm.
And so I think okay, so if you're starting up Helm, and once
Mhm.
you start getting frustrated with Helm, which you will, I promise, eventually, once you get frustrated with Helm, move to customize plus custom tooling or just custom tooling, right? Just don't think that because Helm is bad, customize is going to be better. That's what I thought at first, and it's better in some ways and it's worse in others. But if you build a custom tool, you can just take the best of both worlds.
But then that's a maintenance burden that you have.
It is.
I suppose it's that depending on whether or not that cost benefit is worth it to you, or it wouldn't be to me as somebody just starting out.
Right. Exactly.
Learning.
Yeah. I mean, if you're starting out, go with Helm.
As you said, yeah, exactly. But if you're running, as you are, like lots of stuff in production, loads of moving parts, then that cost benefit is worth it.
Well, the thing is, the cost isn't that huge. I mean, having implemented that tool, the thing we spent the most time on was actually figuring out what we wanted our custom YAML configuration file to look like.
Yeah.
Right.
Spec building. It's always hard.
Yeah. Basically, like what's the design? What's our API? Basically, like what is it? What is our API? What is the interface we want to expose to people who don't want to think about this stuff? But who can if they want. Like the code is accessible to everyone in the org, and actually writing the code that only took a couple days.
Yeah, I figure once you've got the API right.
Yeah.
I was sort of thinking about when Kubernetes updates and there's more stuff that you might want to add into your configurations or sort of be able to configure. You'll need to update your custom tooling in order to give you access to those. But
right. Exactly. And
if it's not actually that much of a code burden, then that seems like a very good trade-off.
That huge. And I think what I loved most about it is that when you have like a legacy detail in your infrastructure.
You can just build that right in.
Yeah, exactly. It's just an if statement in your code, right? And that's that makes it a lot easier if you're actually like writing an actual, like you can use a language you're familiar with. We use Go, but it doesn't matter. You're generating text. You don't care. Like for instance, it's stupid, right? But I mean, originally Pigment was only deployed in Europe. And so we had one production cluster in Europe and one staging cluster in Europe. And how were those clusters called? Well, they were called production and staging. But then we decided to deploy to the US. And so we changed our naming convention. So now it's production US1. And the old cluster is its ID now. We refer to it as production EU1. But you can't rename a cluster, right? And so in our code, there's just this simple variable, which is like we have a cluster ID and we have a cluster legacy name.
Yeah.
And if the legacy name is set, then we use that in certain places. In other places, we actually use the ID. And you can just write that code yourself. It's I think it's much simpler than writing overcomplicated Helm templates or overcomplicated customize components. And honestly, it's just easier to write the code yourself with the loop and if statements, basically.
So the answer to the question then is, should I use Helm or customize or something else? The answer is yes.
Yes, exactly. The answer is yes. And also use a state management system like Argo or Flux. And if you
that's the unifying element here that we're talking about, right?
Yeah, it's what creates the debate. Because if you're not using a state management system like that, then just use Helm. Because you're going to need state management, and Helm does that, right? So if you don't have Argo or Flux, use Helm. It's like the Helm upgrade command is amazing, and that's why Helm is so popular. So just use that.
Right? And if you're coming from more physical infrastructure based, or cloud infrastructure based background, and if you use tools like Terraform or Pulumi, the idea of templating, the idea of having it generate diffs and show you what it's going to do beforehand is going to feel very familiar coming into the Helm world. So there's not new paradigms to learn, basically.
No, I think if you come from Terraform, Helm is very intuitive. Instead of generating API calls, you're just generating YAML, which are then translated to API calls. But I think in the same way there's a debate between Terraform and Pulumi, I think it's the same debate for Helm and custom tooling. Basically, it's, can I do all of this declaratively with this simple language? or do I need to build something custom? And so I need a more powerful, versatile, general purpose language. And that's what you get with Pulumi, right? I mean, you still can use Terraform inside Pulumi, but you have this ability to actually just write Python code, for instance, and that's amazing.
Right, whatever sort of code in whatever language that makes sense for your environment. You know your logic, you know your systems.
Exactly. Yeah.
Right. Yeah. All right. Well, hey, that is an excellent answer to that question. You did evoke the name of the company you work at, and I would be remiss if I didn't give you an opportunity to mention that. So as I mentioned at the top, that Arthur is an SRE at Pigment.
Yes.
In a couple of words, what is Pigment?
Pigment is Excel in your browser on steroids. Basically, users can import their data and then write formulas with a custom Excel-like syntax to transform that data and then visualize it with dashboards. We call this enterprise performance monitoring. Yes. And so the idea is that we mostly sell this to finance teams, for instance, but also HR, things like that. We use it internally. My team uses it to model our cloud spending, right? We actually modeled it. We imported the data from our cloud provider, and we're building a model to try to figure out what is costing us money, how much does this customer cost, et cetera, et cetera. And so we store and process a lot of data, and so that's why we use Kubernetes and databases and things like that.
Excellent, excellent. So cloud economics is a pretty important subject. Getting a hold of your cloud spend is something that makes sense to anybody who's ever touched the cloud. Every single organization, has a use case for something like that by default. If you're using the cloud,
Right.
You could be using Pigment, right? Above and beyond what it is your company actually does.
Exactly. Yeah, it's a very versatile tool. Right now, you can't just sign up. We're not ready for that yet. So we are onboarding customers on a case-by-case basis.
Sure.
That being said, if anyone is interested, hit me up and I'll put you in contact with our sales team, who will be more than glad to figure out how Pigment can help you. Right.
Speaking of signing up,
yes,
sign up for our Behind the Helm Kubernetes newsletter, scaleway.com/en/Kubernetes-newsletter. We will put a nice QR code up, right? So don't worry about that. But if you want to hang up, it is Kubernetes newsletter par nos soins, what we say here. So it was written by us, curated by us. We send that out monthly. And in fact, who actually is writing that newsletter?
I'm trying to pop up. So yeah, okay, the banner's gone down. I was like, yes, it's me. I write that. Or at least I've written this month's and last month's. May well end up doing it going forward. It's a lot of fun. There's also crosswords that I put in them as well. I write crosswords. So if that's your jam, sign up for it. You can ignore all the text, just do the crossword. It's fine.
I might do that.
Yeah.
The crossword's a lot of fun. The first one was not so bad. I think the next few are going to be a bit more difficult.
Yeah, it's a cryptic crossword this time. I grew up doing like the Times crossword, so yeah. If it's way too hard and everyone hates it, then I'll recalibrate.
Yeah.
Excellent. All right. Well, on that note, thank you so much, Arthur, for coming through, for volunteering to be Dr. Kube with us, for taking the questions, and really just hanging out with us and answering some questions, having some great discussions. Really, really looking forward to hosting you in Paris for Kube Talks number 3. Good luck. Break a leg in London for your talk that's coming right up. Once again, everybody, that's WTF is SRE in London, 4th and 5th of May. If you're in the area, Kube Talks is on the 30th of May in Paris if you want to catch Arthur live. Speaking of live, we will be back next week with another live edition. Until then, keep safe, everybody.
Yep.
Thanks a lot. Bye-bye.
Bye.